So we were talking about introduction to chemistry, last class period. So we have to finish, today we have to finish it. Going over the material, all right? Okay, let me get this little, my module 1 to cover chapter 1 and 2. And we have an introduction to chemistry first. So we are going over some of the material last class period. So introduction to chemistry. I'm going to go to introduction to chemistry slides. So share this presentation. We stopped last time around about chapter 2, slide 21, where we talked about, previously we talked about how a theory is created from scientific method. So one of the theories we're going to look at, very important to us, is atomic theory. According to Richard Feynman, the most important idea in all human knowledge is the idea all things are made up of atoms. So the idea that all matter is made out of atoms came from Dalton's atomic theory. Dalton tried to describe chemical laws, 3 chemical laws produced by Lavoisier, law of conservation of mass, and 2 other chemical laws about chemical reactions. 1 of 3 laws were like law of conservation of mass in chemical reaction of matter, law of constant proportion. When a compound is formed between 2 elements, the composition by mass of the 2 elements are fixed. It's called law of constant composition. And when 2 elements combine to form 2 different compounds like carbon monoxide and carbon dioxide from carbon and oxygen, the ratio between the second element oxygen is a multiple ratio, whole number multiple ratio, 1 to 2. Masses are simple whole number ratio 1 to 2. It shows that there are 2 oxygen atoms in carbon dioxide, 1 oxygen atom in CO, creating 2 different compounds. So these 3 laws were explained by Dalton using his first atomic model. It went beyond the laws and observation at the time to predict behavior of matter. So it is a groundbreaking step. He came up with the idea to explain the 3 chemical laws. An atom is the smallest particle of element that can be identified as the element. He defined the element. Element is a pure compound which consists of 1 kind of atom, like hydrogen, copper, elements have that same atom. All matter is composed of atoms. Dalton proposed correctly that idea. So just like Dalton atomic theories establish a strong experimental support are most powerful piece of scientific knowledge. Some people say it is just a theory, as if theories were speculations. Theories are based on facts, not speculation. So well-tested theories become closer to truth as we can get in science, well-tested theories. So we're going to look at atomic view of matter after we came up with the idea of Dalton's atomic theory. If you look at the cup of Coke here, soft drink, Coke, you can see that in the inside we have a macroscopic view or general view. Ordinary view is just the glass with brown liquid in it, dark brown liquid. But in the mind of chemists, in the atomic view, there are water molecules, carbon dioxide molecules, and sugar molecules. On a pencil head, where you write on the paper, you can see that the carbon on the pencil head is made out of carbon atom, elemental carbon atoms, graphite. On the hand, there are proteins.
Because y'all not about to find me. Y'all not about to...
You have a question?
No.
All right. On the hand, in the picture, the hand is made out of muscles and bones and complex structure, but the outside is proteins. Proteins are amino acids, then that you can see a picture of atoms and molecules making up the hand. So that's the atomic view of matter. So we have to come up with idea that when you look at things in chemistry, we just not only look at macroscopic view or the ordinary view, we have to go beyond and little bit think in terms of atomic structure. So that's what we're going to practice. So matter is made out of molecules and ions. Atoms are the basic unit of matter defined in the structure of elements. Elements.
Oh no, they don't let you send it. Oh wait. They said only the host could share the meeting.
Can you guys stop talking or just ask the question if you have one?
I think he just gone. Huh? He just teaching.
What is the problem here? Who's talking? Anna, can you mute your phone speaker? Elena Howard. Elena Howard. Okay, the time being is quiet now. Please don't disturb. You understand my concern. I had to conduct a class here. Then you guys start talking in the background. It become difficult for me to do my job. Okay, the atomic view. So we talked about this. Atom is the basic unit of matter consisting of elements. Elements have only one kind of atom, like copper, hydrogen elements. Molecules are a group of atoms bonded to each other, like water molecules that are produced in a chemical reaction. Ions, some matter composed of ions, like sodium chloride, salts, consisting of ions, cations and anions, positive ions and negative ions. Ions are atoms which acquire electrical charge by losing or gaining electron. Losing, they produce positive charge ions. So we can explain the structure of the matter using atoms, ion molecules, and ions.
Well, if you talk about the letters, I missed it. I can't even hear him no more.
What's the problem? You have a question? Do you?
I said I wasn't in class at first. I'm sitting in your classroom as of right now. I said if you call my name, then I'm here.
Okay, you had to sign up the chat box.
Okay.
All right. This is your first time here?
Yes, sir.
Okay. Normally, if you have a question, you ask and turn off the mic, okay? So there are crosstalk between people that can distract us from doing the material, all right? Just sign up the chat box.
Yes, sir.
Okay, thank you. Elements are, I'm trying to continue this chapter, few slides now for 5 minutes now. I'm getting disturbances. What are elements? Elements are composed of only one kind of atoms. One kind of atom. There are 115 different elements based on identity of the atom: hydrogen, phosphorus, oxygen, etc. So one thing that elements have is they cannot be converted into other substances, because elements are the simplest pure substances that are on Earth. So they participate in energy transfer as heat, light, electricity, and sound and magnetism. All matter exchange energy as light, electricity, sound, and magnetism. We're going to look at the forms of energy that elements and compounds can participate in. Only atoms could be destroyed by high energy particles like electrons, high energy electrons, to break up the atom, releasing enormous amount of energy. You heard about a nuclear reaction to produce energy, large amount of energy producing an atomic bomb. The atom is destroyed, but normally this is nothing to do with us. In chemistry, we only look at atoms and their changes into compounds, and we never destroy atoms during the chemical processes. Ionized atoms are atoms that have acquired electrical charge, electron, or lost electrons. An anion is a negatively charged ion. Is formed from the atom acquiring one or more electrons. Cation is a positively charged ion produced from an atom by losing electrons. So ionic compounds which contain anions and cations are called electrolytes. When they dissolve in water, or when they melted, they conduct electricity. They are electrical conductors when molten or dissolved in water. So if they are not ions, matter is not made up of ions, they are called non-electrolytes. Matter made out of atoms and molecules are non-electrolytes. Nature of these elements. Many present as ions or combination with others. Now, we are talking about ionic ions, nature of these elements or ions in the forms of ions. Many present as ion or combination with others. Chloride is present with neutral, negatively charged chloride is present as anions with the sodium cation. Phosphorus is present in phosphate, calcium phosphate. Calcium is the positively charged ion, and cation, and the phosphate is the negatively charged ion. Sodium and potassium present in the body. Sodium ions and the present sodium and potassium ions present in the body participate in propagating nerve signals. So your brain sends signal to your muscles through these neurons, which have sodium and potassium exchanging process. Sodium chloride, which is ionic compound, contain ion, cause blood pressure. Iodine is present as iodide ion. So iodide is present in salts which are needed for thyroid glands. Calcium is present in calcium phosphate in the teeth and bones. So there are many matter that has made out of ions. That's what we're talking about here. Matter made out of ions. Now, chemistry is the branch of science that studies the composition and property and change that matter undergoes. So matter is atoms, molecules, and ions. Their changes are the ones we study in chemistry. For example, hydrogen and oxygen molecule produce two water molecules. So that produce in a chemical reaction. The matter substances, identity of the substances, beginning and the end is different. It's a chemical reaction. Matter is get transformed during the transformed during the chemical reaction. A compound is a pure substance. Just like elements are simplest pure substances, compound is a pure substances made out of two or more different elements. For example, water. Water has hydrogen and oxygen combined in the ratio of 1:2, one oxygen atom to two hydrogen atoms. So there are complex molecules like DNA here on the right side. DNA is made out of base pairs, sugars, phosphate. It's a backbone of DNA molecules. So idea is, unlike elements, molecules are grouped of two or more atoms held together by chemical bonds, just as in water. Molecule always have more than one atom, okay? Ordinary things we see are composed of atoms and molecules and ions we call chemicals. ordinary things, we think they are not chemicals, but they are chemicals, just like it's not in the pure form, but in the laboratory, we have pure chemicals, element substances and pure substances. The air we breathe is composed of oxygen and nitrogen mixture. The water we drink is bulk of that is water and dissolved ions in it, minerals. Toothpaste, Tylenol, toilet paper are complex substances, complex mixtures of several substances. Building materials like cement, bricks, chemical substances which are composed of complex mixtures of several things. Chemistry explains properties and behavior of chemicals by helping us understand the molecules that compose them. So we have to use chemistry, we have to use the idea about what is composed of that material. So we go to either atoms or molecules or ions and describe their properties. What in the world is in chemistry? If you look at the picture down there, they are made out of matter. Matter is anything that has mass and volume. So therefore, they are complex mixtures of matter. So you have to understand everything is made out of chemicals.
In progress. Damn, I hope you came.
All right, you guys taking a break, huh? Chemistry requires calculation. Now, when we describe properties of matter and their chemical reactions, we need to do calculations, quantify observation in terms of mass, volume, etc. Important tools in science. Quantification also be to specify the differences precisely. So numbers, using number and a unit is very important. Measurements. One of the measurement of matter is temperature. You may find that one sample of water is 40 degrees Celsius and another is 44 Celsius degree. There's a temperature difference, that the heat content is different, and matter also change physical state depending on the temperature. So you need to really carefully study material that we cover in this course. So you will be kind of rewarded in a way by having an analytical mind, developing an analytical mind about your surrounding and what you see. So it will help you. So we deal with environmental chemistry in this course. So to be successful as an environmental chemist, you must be curious and imaginative, willing to do calculations. When you see a problem in the environment, you have to find out exactly what is in the pollutants and measure and calculate. And you have to be committed to learning. And before you do any calculation, do your homework. Okay, I'm not planning here to turn you guys into chemists. Don't think that I am trying to do that. I am trying to give a view of chemistry from a chemist's point of view so that you can take away that knowledge to environmental problems. I want to show how chemistry is relevant to the environmental materials we use, food, drugs, and your health, and promote critical information in the media, assessment of information critically in the media, and new ideas about materials, environment, drug, and health. And I like to increase student participation. So like we said, we are made out of substances which compose of atoms, molecules, and ions. On the average, we are made out of 60% by weight, of 60% water by weight. Hence, our major components are oxygen atoms and hydrogen atoms or elements. Muscles and fats contain carbon and nitrogen, in addition to oxygen and hydrogen. Muscles are proteins, fat is fatty acids. Thus, we make up hydrogen or carbon, oxygen, nitrogen make up more than 90% of our weight, including water. In terms of number of atoms, we have much higher hydrogen percentage of atoms. And we also lose water as we age. We kind of, so keep drinking more water, keep you younger, probably. There are other elements in the body, tracer elements, proper anti-aging effect. Selenium has anti-aging effects. But if you take a lot of it, it becomes toxic. Manganese are present in metalloenzyme. Some enzyme that does do something in metabolism of metabolism of organism use metalloenzyme that contains manganese ions. Molybdenum is present in another enzyme called xanthine oxidase. ACE prefix is used to signify the enzymes which are physiological catalysts. Catalyst is a substance that increases the rate of a reaction without undergoing any change. So there are a lot of elements in the body. Calcium, chlorine, that percentages are given where they are present, dietary source of these elements, important elements. Zinc is in seafood and meat. Sodium is in table salt. Potassium is in everywhere. Phosphorus is in eggs, meat. Magnesium is green vegetables. Iron is in beef and fruit. Iodine is in seafood. Iodine is required for thyroid gland functions. Thyroid gland doesn't work properly when you have a thyroid problem and thyroid gland doesn't absorb iodine properly. So we summarize in this chapter, Introduction to Chemistry. So we talked about scientific method and atomic theory, Dalton's atomic theory, description of matter as atoms and molecules and ions, and some example of composition of human body. So I am done with introduction. So I'm going to go to chapter 1 that covers real environmental chemistry. Okay, the topic of the chapter 1 is portable electronics, the periodic table in the palm of your hand. What do you mean by portable electronic? The periodic table is in your cell phone. There are a lot of elements that are used in making cell phone components. So we're going to learn some of the elements which are used in your cell phone. So that's an idea that we're going to explore chemistry through one sample of from cell using a cell phone. So you will learn about different components in your portable electronic devices during this chapter. So we use periodic table to guide us design of the table of element to design of your cell phone. What are the rocks and how does we isolate purify metals from natural sources? To produce different compounds that is present in cell phone that we have to extract metals from natural sources like rocks and minerals. Then we're going to learn about that, how we do that in this chapter. How is ordinary and sand is converted to silicon, fundamental component of processor chips. Silicon is a very important component of a cell phone. The cell phone has chips. Silicon is the basis for my computer chips used in cell phones. Therefore, very important compound element. Silicon is an element made out of silicon. How is the sand converted into glass? Glass also is a building material for many things. Cell phone has a screen and with specific properties, crack resistance and all that. So we will be looking into glass also in trying to explain the properties of crack resistance in cell phone devices. We also look into environmental implication of fabricating these compounds, different materials in the production of cell phone, and how the recycling could be done, recycling of portable electronics devices could be done. So that's the basic idea that we're going to cover in this chapter. So we're going to, like I said before, we're going to look into properties of electronic devices, role in chemistry, how it plays an important role. List some of the desirable attributes of cell phone. and some that would like to see in the future. Cite 2 elements that combine to form substance important to your cell phone. We want to look into that. What is the expected lifespan of your cell phone? Lifespan of my cell phone has been about 3 to 4 years. They become obsolete. So how many of you use cell phone more than 3 years? 4 years probably. With your new cell phone plan, you always get a new one, but you pay higher prices for that. How does touch screen work? So touch screen has a conducting layer on the surface made out of tin oxide. When you put your finger on it, it makes electrical contact with the cell phone, just like any touch screen on a computer, and that touching initiate a computer chips to start a process for icon and things like that. So now all the touch screens are made for fingers or touch or certain pens. The Galaxy has certain pen which can give the same effect as touching the screen with the hand, but not many other things can do the same thing. You cannot use a pencil to do that. We are going to little bit more introduction to matter again. Matter is made out of 3 physical states. Do you see 3 physical states here? The water vapor in the air, in the atmosphere, water vapor in water, liquid water in the ocean, and solid water, ice in the ice or snow in the picture. The matter is made out of three phases. Depending on the temperature, that matter change physical state. Matter can be classified by phase. What is a phase? Phase is a distinct state of matter, like liquid, gas, solid, and plasma. Matter is mostly made out of liquid or gas or solid. Plasma is present in high temperatures. In a star, all matter is composed of plasma. The broken up atoms into their subatomic particles is high temperature, produce plasma. So you need to know microscopic properties of solid, liquid, and gases. Properties of gases are, macroscopic properties of gases are shape, filling its container, how it fills container, whether it has a volume, definite volume, or definite shape. So if you look at 3 main phases or states of matter, a phase is liquid phase, gas phase, solid phase, like states are identical, are synonymous with phase, state and phase. So there you can look in the table. Take the shape of the container. liquid and gases take up the shape of the container. Solid will have its own shape. Completely fills its container. Only gas completely fill the container. Definite volume. That solid and liquid has definite volume. Definite shape. Only solid has a definite shape. The shape of the liquid and gases are the shape of the container. Now, what is a physical and chemical property? Physical property is something like boiling point, melting point, color, odor, solubility, state of matter. There's a description of phase changes, state of change in state. Boiling point is liquid going to gas. Color is the color of the material. Melting point is solid going to liquid. Changes of solubility is something going into water. One thing that you have to understand is physical change involves same substance. While matter is changed, substance remain constant. There's no change in substance. When water becomes ice, liquid water becomes ice. It has the same thing, water molecules. On the other hand, chemical properties are like flammability. It talks about chemical reactions between matter and the other substances. Flammability is how matter reacts with oxygen. It describes a chemical reaction. Toxicity is there's something get bonded to enzymes. Substances mercury get bonded to enzymes in the body and create toxicity. That metals are bound on metal enzymes now. Acidity also change substance, remove as water, hydrogen ions or hydroxide ions. Then that's a chemical change. Reactivity, oxidation, combustion, radioactivity are not physical changes. They are chemical changes. The one thing that you need to understand is during a chemical reaction, chemical change, matter is converted to new substances. For example, oxygen, hydrogen get converted to water. Then you start with two elements and you end up with a new substance called water. So chemical change, understanding chemical change and physical change is very important. Check out the interactive simulation of atom molecule in different states. That's a video that you can watch. Answer following questions. Provide an example to support each of your answer. What phases have definite volume? Definite volume only copper has. Copper and liquids. Definite volume. For solids and liquid have definite volume. The table explains it. Definite volume, solid and liquid. So what phase or state has a definite shape? Solids. What phase take up the shape of the container? Liquid. What phase completely fill its container? A gas phase. The matter is composed of pure substances and mixtures. Pure substances, we talked about it in the previous chapter, are composed of elements and compounds. Mixtures are mixtures of elements with different elements, or compounds with elements, or various combination of elements and compounds. Mixtures are more complex than pure substances. They have different pure substances. A mixture is like a water and sodium chloride is a mixture. It's a homogeneous. It could be heterogeneous. Homogeneous mixture is a mixture where the composition is uniform throughout, like sodium chloride water, sodium chloride dissolved in water, so salt solution is homogeneous. So heterogeneous is like a garbage can. It has different composition in various parts of the container. So as we said before, pure substances could be elements containing only one type of atom, for example, silicon or copper. Compounds contain two more elements, two or more different elements. For example, silicon dioxide or water. There are so many examples. Mixtures maybe with heterogeneous, with composition that varies throughout the sample, such as gravel. If you take a piece of gravel, it has different regions, different minerals. It's a complex heterogeneous mixture. Homogeneous mixture have a uniform composition throughout, such as a sugar water solution. So we're going to stop at this point. Okay. I will put these classes on Canvas web page with the date for today's 22nd, right? 23rd. So you can go back and read if you have to listen to it again. All right. Have you guys signed up the chat box?
Signed up for what?
On your name typed in the chat box.
Oh, all right. I'll do it.
Okay. I keep track of people who are attending. So I had to know who is coming and not coming. Okay. All right. I'm